All right, so here we are starting geometric sequences. So geometric sequences are different than arithmetic sequences, um, obviously, because they have a different name. So I assume they would be different. Wow, this is easy. So what we're going to be doing is we're talking about what makes them different. So which of the following, can you tell which one of these is an arithmetic sequence? So you can tell things are an arithmetic sequence because they have a common difference. That's how we can tell. Have a common difference. So, in other words, how do I get from 1 to 4? So 4 minus 1, I went up by 3. 7 minus 4, up by 3, up by 3, up by 3, up by 3. That's a common difference, meaning we added to get to the next one. So the common difference is 3, so this is absolutely an arithmetic sequence. Okay, if you look at number 2, same basic idea. 10 minus 15, that's negative 5. 5 minus negative 5. So each one of these, from here to here, I'm going down by 5. So the common difference is negative 5, so it is arithmetic. We look over here at number 3. 10 minus 5 is 5, okay. 20 minus 10 is 10. 40 minus 20 is 20. Those are going up by different amounts, so this could not be arithmetic because there is no common difference. No D, no common difference. Okay, how about this one? Well, this one is crazy because it's negative then positive, negative, positive, negative, positive. There's no way this could be arithmetic. But just to show you that this is going up by 33 here, and then from here to here we're going down 66, and then from here to here we're going up 132. Yeah, there's no way. No way. So it's not arithmetic. So an arithmetic sequence is a sequence that has a common difference. It means it goes up or down by the same amount by adding. So a geometric sequence, I don't know if you guessed it yet, but we multiply to get to the next one. So it's a sequence of values that follows a pattern by multiplying a fixed amount, not by zero. Obviously, that would just be a bunch of zeros. Times each term to arrive at the following term. So instead of a common difference, we now have a common ratio. So common ratio is divide one term by the term before it. So to figure that out, each one of these are both geometric. So to figure out the common ratio, we just take one term and divide it by the term before. Just like we subtracted with an arithmetic, now we're dividing. So the common ratio is 10 divided by 5, or 2. And we could do it this way, 20 divided by 10, or 40 divided by 20. Okay, so it's going up by multiplying by 2. So a common ratio is we multiply to get to the next term, and that constitutes, a geometric sequence. So geometric is multiplying by something. Now, it doesn't always have to be a whole number or even a positive number. You could multiply by a fraction and get smaller, absolute value-ish smaller, and you can multiply by a negative to get, to change a sign. But for this particular one, your common ratio is negative 3 divided by 6, which is negative a half. So not only are we multiplying by a negative, so it's switching the signs. It goes from positive to negative to positive to negative, but you're also going down in, in size of the number, so in absolute value, size of the number. But this one, you could have also taken 3 over 2 and divided that by negative 3. And remember, keep, change, flip, 3 over 2 times the reciprocal, negative 1/3. So common ratio is negative a half. Same thing for this one, you would get the same idea. Now, if you know it's a geometric sequence, you don't have to divide each one of them. You just have to divide 1 by 1 before it. And if it were me, I would pick these two because negative 3 divided by 6 is a lot easier than negative 3/4 divided by 3/2. So a geometric sequence has a common ratio. And if you know it's a geometric sequence, you take one term and divide it by the term before it. All right. Hope you understand. Have a wonderful day. And I hope to see you sometime in the near future.